Okay.
Hi, Brendan.
All right. So let's go ahead and do what we're going to do today. So basically, what we're going to look at now is we're going to do some matrix operations today. We're going to stick with the basic operations. Okay. Kind of go over how those work and things like that. All right. So does anybody have any questions on what a matrix is? You know, kind of the very, very basics of how they work, like, you know, order, anything like that. You should. It's pretty straightforward. Okay, good. All right. So we won't bother with that. Instead, let's just look at the matrix operations. Okay. So today, come on, behave. Matrix operations. Okay. Matrices are like kind of like vectors in that there's a bunch of different things you can do with them. Okay. And so the basic operations are going to be addition and subtraction. Okay. Scalar multiplication. Okay. A special one called matrix multiplication. Okay. Then one that's kind of unique to matrices called transposition. Okay. And then two others. These aren't operations, but there's things you do with a matrix. Kind of things you find out about a matrix. The first one is finding the matrices, finding what's called the determinant. Okay, and then the last one is finding the inverse of a matrix. Okay. Now we obviously won't get to everything today, but these are kind of the things we're going to do right immediately with matrices. Okay. What we're going to do today is we're going to go over the very easy, basic pieces of arithmetic. All right, which is addition, subtraction, scalar multiplication, and transposition. Okay. The other thing we're going to do is we're going to look at two special matrices that pop up from time to time again. Okay. But they're just special matrices that you'll see in problems. Right? Any questions about this so far? I think this is just a list of what we're doing. All right. Let's start with the first one. Okay. Matrix addition dash subtraction. Okay. All right. So basically, with addition and subtraction here, okay. The key is all you're going to be doing is adding like element to like element in a matrix, or subtracting like element from like element. The key is the order of the two matrices you're adding together has to be the same. Okay? So basically, with addition dash subtraction, we're simply adding element to element in the same position, and the two matrices you add or subtract must have the same order. Okay? All right, so let's take a look at an example of addition and subtraction. We'll do it with, we'll make two matrices here. We'll do matrix A. We'll make it be 3, 5, 9, 2, 6, 1. And we're going to add to it matrix B, which will make it 8, 2, 2, minus 4, 11, 6. Okay? Alright. Addition is fairly straightforward. All I'm going to do is do 3 plus 8, then 5 plus 2, then 9 plus 2, then 2 plus minus 4, then 6 plus 11, etc. Just going across just like that. And my sum is going to be in the same position. So when I do 3 plus 8 to get 11, it's going to be in the same spot as the 3 and the 8 were. 5 plus 2 gives me 7, same spot again. 9 plus 2 is 11, same spot again. I must subconsciously want a Slurpee or something, because I've written 7 and 11 up there twice. Alright, 2 and negative 4 make negative 2, you add them together. 6 and 11 make 17, and then 1 and 6 make 7. Alright, and there you have it. So that's really all there is to the addition. Okay.
That becomes matrix C. Matrix C.
Yeah, we could call that matrix C if we want to. Okay. Or something like that. There. Okay. If I were to subtract this matrix, these two matrices, you would do the same exact. It'd be the same exact kind of setup, right? So if I use these two matrices again, okay. Alright. Basically, you're just going to do the stretches. It would be 3 minus 8, which is minus 5. 5 minus 2, which is 3. 9 minus 2, which is 7. Okay. 2 minus minus 4, which is 6. Okay. 6 minus 11, which is negative 5. And then 1 minus 6, which is negative 5 again. Okay. And that's all there is to it. Any questions on how that works? Okay. Should be one of the easiest things we'll do with these matrices is the adding. By the way, like adding, subtracting, and scalar multiplication, they follow the standard rules of algebra involving just distribution and parentheses and things like that. So if I had like 7 times a plus b, I do a plus b first and times the result by 7, things like that. Yeah.
So if you had two matrices that weren't, or one was, say it's a 2 by 3 and another one's a 3 by 3, could you substitute a third row in the first one, first matrix, like x, y, z?
Okay. No.
To be able to add it?
You wouldn't actually be able to add them at all, and so you would in fact, they just can't be done. And so that brings up our next question: what happens when they're not the same order? So what happens if I have two matrices that are like, basically the matrices must have the same order. Okay, so if I did something like 2, 5, 6, 1, and add to that 8, 3, 2, 7, 1, 4, my answer would actually just be can't be done. Okay? And if you wanted to give an explanation, it's because the orders are different. Okay? Now, I see what you're saying. Could I add like another column here to line them up and just call that column X and Y? Unfortunately, no. I wouldn't be able to do that. Because what I would then be doing is changing this matrix so it would no longer be the same matrix it was. Okay? Does that make sense? So if I added a column to this, if this was matrix A, adding a column to it would no longer make it matrix A. It would be some different matrix. Okay? That ends up being a big deal kind of later on when we do matrix multiplication. Okay? Any questions though there? Gotta have the same order. Alright, good. Moving on. Next, kind of the next big subject here, scalar multiplication Okay? It actually works the same way as vector multiplication does. What you're going to do is you're going to multiply every element in the matrix by the same number. Okay? So okay? So an example of that, just so you get the idea, we'll keep it short. I might do 3 times like -2, 5, 1, 8, 4, minus 3. If I did this right here, be 3 times -2, -6. 3 times 5, 15. 3 times 1, 3. 3 times 8, 24. 3 times 4, 12. And then 3 times -3, -9. That's it. That's all there is to scalar multiplication. Scalar multiplication doesn't care about order, it doesn't care about things like that. The only thing that matters is you're taking that constant, you're multiplying through. Okay? Any problems there? Alright, good. So it's a very easy, simple process. Again, as I was saying, typically, when you're kind of gaining up multiple different operations involved with 2 matrices, just follow the standard order of operations. So if they're in parentheses, do the work in the parentheses first. If there's a scalar and then I'm adding something, you multiply, then add. That sort of stuff, okay? Any questions? Alright, good. Okay, now, we're going to go ahead right now and skip matrix multiplication. We're going to save that for Monday. Matrix multiplication is a bit more involved. It's not so straightforward. So we'll go down to the last one on that list, transposition, and we'll look at that one right now. Transposition is actually a fairly kind of easy, it's a very easy process to do. All you're doing is you're changing your rows into columns, okay? Your columns then become rows. So it's like basically, it's almost as if you're taking the matrix and turning it 90 degrees, okay? Except it doesn't quite work exactly that way. So we've got transposition. Okay, this is where you transposed. Okay, when its rows, excuse me, become columns, etc.
What happens to the already existing rows or columns?
Basically, when you make that change, those columns actually become rows.
Oh, okay.
So again, it's when you transpose, you take the row, it becomes a column, and then the columns that you had get switched to become rows. Okay, when you do it, let's take a look at an example. Okay, if I had matrix A being equal to 3, 2, 5, 8, 1, 6, okay, then A transposed, the transposition of A, okay, is going to be 3, 2, 5, 8, 1, 6, okay. First row became first column. Second row became second column. That's it, okay? Likewise, notice what happened to the columns. My first column turned into my first row. Second column became second row. Third column, third row, okay? So it kind of neatly works